Hi, my name's Tal Hurwitz. I'm a librarian and archivist, and I'm also a nationally licensed emergency medical technician. In this video, I'll be going over experiences and the development of an open source ontology designed to work with basic EMT protocols. What is an ontology? There are two primary uses of the word, related to each other but distinct. First, ontology is a type of philosophy referring to the study of being, or the nature of reality in itself. Ontology was notably discussed in Aristotle's works on the metaphysics and categories, and along with a lot of his other work, these ideas spread through those large parts of the world influenced by Greek culture. As far as we know, the word ontology proper didn't exist until the 1600s, but the concept existed in different forms as a type of metaphysics. What I'm discussing here is the second type of ontology. Like a catalog, index, or taxonomy, an ontology is an organized representation of a system. So as not to confuse the terms, we can say ontology, referring to the field of study in general, or an ontology, specifying one in the particular, referring to a constructed ontology. One thing which differentiates a constructed ontology from a taxonomy, as we see in this tree on the screen, for example, is a greater capacity for representing dimensionality along multiple axes. It can establish your own relationships. Tom Gruber popularized the term ontology in 1993. In this context, a conceptualization refers to the objects, concepts, relationships, and other entities that exist in some domain of knowledge. This definition has been debated, sometimes criticized as vague, and worked with for years, but as the field grew into more application, increasing terminological specificity was needed. Here's a definition of ontology from Dr. Barry Smith. We have an ontology as a representational artifact comprising a taxonomy as proper part, whose representations are intended to designate a combination of universals, defined classes, and certain relations between them. As a quick digression, Tom Gruber and his company eventually created an ontology called Siri, which he quickly sold to Apple. Computational ontologies can be used in any fields which require deriving meaning from data, which is pretty much everything at this point, and as examples are very often used in biomedical informatics, natural language processing like Siri, and machine learning. What is an EMT? First, Emergency Medical Services, or EMS, is a medical support system which include all services dedicated to emergency pre-hospital patient assistance. An emergency medical technician, or EMT, is part of this system and is an active medical practitioner licensed to interact with patients and perform certain procedures. There are several levels of American EMT training, which vary by state, and delineate their permitted scope of medical practice. By state, there are usually 3 or 4 levels, which can be generally classified into basic, intermediate, and advanced. The highest level of EMS provider is referred to as a paramedic. EMTs respond to emergency situations. In the United States, we have the 911 telephone system, in which emergency services, including police and/or EMS personnel, are called to the scene of an active emergency. If the emergency is medical in nature, an ambulance carrying EMTs will be dispatched to the area. Protocols and legal scope of practice for EMTs also vary by state and sometimes municipality. There are continuing efforts to create a standardized national EMT licensure and protocols. Right now, the National Registry of EMTs certifies EMTs who have passed state licensing requirements to practice on a national level, which excludes a couple of states which have opted out of this system. They have differing reciprocity agreements with the national system. First, I should say that I think that regardless of local differences, EMT treatment protocols don't drastically vary based on region. You're still going to perform CPR in the same way and approach a patient in the same way. There are some minutiae and some things that aren't quite so minute that are a little bit different based on area. So, for example, these are the BLS protocols. That's EMT basic protocols for New York City. That's a narrower scope than even state. An example of procedural difficulties. My home state of New York doesn't participate in the National Registry and has additional protocols and testing requirements. I'm registered as an EMT on the basic level in both the state of New York and nationally. For me, these were two separate sets of licensing applications and additional examinations. The most difficult part in obtaining these two different licenses was navigating the bureaucracy of specific requirements for each. I'm also required to deliver CEUs to both New York State and the national organization. In general, states are trying to work to integrate their requirements, protocols, and scope of practice to a national model. While states try to do this, their resources are necessary to clarify what an EMT is really supposed to do in a national context. And this difficulty is compounded by differing levels of certification. On the broadest level, the most significant differences between an EMT basic and higher levels of certification are that EMTBs don't intubate. Generally, there's some exceptions, generally don't administer medication that the patient doesn't own, but if it's indicated, we can help somebody take their own medication. And we don't administer or assess EKGs. And these levels of licensure vary by state. One great project in the direction of national standardization is by the National Association of State EMS Officials, Directors Council. They currently have a set of national EMS clinical guidelines, which is not intended to replace local scope of practice, but to help the goal of integration by presenting a baseline to work toward. This document includes all levels of EMT practice, which presents some difficulties in going through it. States are responsible for defining scope of practice and protocols. The New York State Department of Health produced their latest version of the statewide pre-hospital treatment protocols in 2016 and regularly provides updates to certain sections. In New York City, we have a further set of protocols, specialized for EMTBs and certified first responders. There are no New York City examinations. Individual EMT agencies may have their own modifications to protocols and scope of practice. I'm not sure if those can be considered resources so much as additional things to remember. Where conflict exists, the rule is to default to the most narrow authority and correspondingly limited scope of practice. The standard textbook for EMT basic classes nationwide is Emergency Care and Transportation of the Sick and Injured by the American Academy of Orthopedic Surgeons. This is colloquially referred to as the Orange Book, and I think they're up to the 11th edition by now. Regardless of all this, protocols are similar, and the individual EMT is expected to keep any significant differences in mind where they're practicing. A great deal of EMT practice can be represented as a decision tree based on observation and interpretation, and on the knowledge of the human organism and an understanding of potential traumas and medical abnormalities. Decisions involve both a cognitive act on the part of the EMT and a performative act, physically acting upon the patient in some specific manner to achieve a desired outcome, and often using a tool to do it. The image here is a flowchart from the New York State EMT protocols. The EMT basic initially operates at a broader level of granularity than a surgeon, for example. As decisions and determinations on how to proceed continue, procedures may become more narrow in scope. Let me just skip ahead a bit. These are examples in basic formulants. I'm getting ahead of myself, but these are examples of potential classes and subclasses in basic formal ontology for some of these problems with the cardiac-related difficulties. When we represent processes typical to the human organism, for example, breathing is on this list, standing, talking, or even thinking, and typical anatomical objects, we have the basis for representing abnormalities of these processes or objects. This is important. It's not within an EMT's scope of practice to diagnose, suspect conditions, and stabilize the patient in accordance with our suspicions as we transport the patient to a hospital where they establish a diagnosis. How can ontologies help? The important questions. What could be wrong? And what do I do next? Most databases use a closed world assumption. This means that the system generally assumes it has complete information. If you assert there's a Macy's department store in New York and query, is there a Macy's department store in Chicago? The answer will be no. OWL uses an open world assumption. This means that the system generally defaults to assuming it has incomplete information. If we query, is there a Macy's department store in Chicago? The answer will be, I don't know. For our purposes, this means that even with incomplete information, Protégé can infer a whole list of potentials, multiple answers to what could be wrong based on whatever patient information you've established. Similarly, it can infer a list of what do I do now based on what you've already done and potential conditions. These are critical points, and I think a fundamental reason that computational ontologies have wonderful applications in modeling complicated procedures. Particularly in a pre-hospital setting, you always have incomplete information until a diagnosis is established. In a hospital setting, any medical professional needs to start with this open world assumption. Tentative diseases do not exist as entities. A patient doesn't have malaria of type tentative or broken arm of type tentative or typhoid of type tentative ad infinitum. Evaluative techniques are used to determine a diagnosis, at which point one treats for the diagnosis. In Protégé, you can close the system with things like logical declarations or property assignments, or you'd never be able to retrieve data items. And often you have to do that. This is the inverse of a database model where it gets tricky to say the word maybe. Relatedly, you have to declare that individuals are logically different. Protégé won't reason that. So, reference ontologies are designed to represent entities in a particular domain, like an ontological lexicon. Application ontologies are designed to accomplish a particular task or function. Often, application ontologies take the knowledge bases already established in reference ontologies and extend them to perform specific tasks. This is like using the dictionary in order to be able to speak a language. The way in which they're extended might make them less interoperable with other ontologies, but allow them to do things. Again, how can ontologies help specifically? Siri, my patient is ANO times 1, HR is 30, and he's cool, pale, and diaphoretic.
That's not nice.
Okay, we have some comprehension problems. Maybe if I say one thing at a time. Siri, I've gotten the airway open. What do I do next?
What kind of businesses are you looking for?
Okay, that was silly. Even if Siri's ontology specialized in the appropriate domain, natural language processing would take too long. You don't have the time to verbally provide information during an actual event. And this is the first sort of thing that comes to mind when one thinks of a procedural ontology. But potential use cases for EMS application ontologies are in training scenarios, simulations, and maybe in reference en route to the emergency, where you really might have time to enter information. We saw a little bit of this already. BFO is another kind of ontology. This is a formal ontology, analytic metaphysics in the Aristotelian sense, which attempts to provide a logical account of parts of reality. from which a taxonomy of anything in reality can be represented. It's domain neutral, which means that it's intended to work as the top level of any other realism-based ontology. By instituting categories in the sense as the highest level of ontological entities, ontology designers have, first, importantly, an existential starting point for work rather than creation out of nothing. Secondly, a well-considered starting point. And participating ontologies immediately have fundamental points of interoperability. This is a good starting place for describing an ontology of EMT protocols insofar as EMT protocols exist in reality. Actions, especially things like procedures, in which one thing acts on another thing, require a lot of thought to conceptually represent accurately. Reference ontologies generally don't require a lot of procedural modeling. The ontology SNOMED CT, as an aside, the SNOMED CT and other taxonomies often have appropriate terms, but they're logically and hierarchically inconsistent, or they don't adhere to the principle of ontological realism in any real way. I suggest that what happens is ubiquitous biomedical ontologies, which are nationally funded and which reference procedures like SNOMED does, are also more likely to try to incorporate insurance and billing into their taxonomy. And that makes the entire structure a fractured compromise between billing representation and reality representation. And procedural terms are partially delineated with respect to how a procedure can be billed. To the right is an excerpt from the New York State 2008 EMT protocols. I have highlighted procedural entities in green and probably less complex or more domain-specific terminology in red, like mechanism of injury is domain-specific terminology. This is the information that's given in the New York State 2008 EMT protocols verbatim. Each of the terms in green refer to procedures that are beyond the scope of this general approach, like establishing, using, noting, requesting, and considering are all complex human processes that have application beyond the domain of emergency medical services. Looking at other areas of medicine which gather information about actions, performed actions, I found a huge and growing field of information about computer-assisted surgery. This includes everything from robots helping to improve surgical precision to imaging and diagnosis. In those areas where computers directly assist, processes have to be represented in this field in some form. And a growing approach is to model from a knowledge base. S3PM is a project with a dual focus. One is to study and figure out ways to represent surgical processes models from descriptions of surgical procedures. And the other is to study and provide adaptive scenarios, primarily for surgical training simulations. And these are clearly complementary tasks. The developers recognize the necessity for a descriptive language for surgical processes and created an ontology designed for procedural surgical modeling called OntoSPM. The developers of OntoSPM state that their work is in the preliminary phase. I think it's pretty astounding for being a preliminary project. It's already been adapted for use by a surgical ontology called LAP OntoSPM, an ontology of laparoscopy. However, it's not widely disseminated, so it's not available through the online bioportal repository or other resources. As a subset of the S3PM project, OntoSPM is an ontology designed for surgical processes. A stated goal is to create, quote, a core ontology of surgical procedures suitable for S3PM as well as other projects, unquote. The designers accordingly and thankfully made this project open source. Like other open source core ontologies, OntoSPM adheres to principles of interoperability. In practice, this means that pay-for-license or closed ontologies are discouraged from use. The authors specifically cite SNOMED CT as an example of an ontology that they really, really did not want to use. What the developers did was choose open source biomedical ontologies as their reference point. And since their ontology was designed to model real procedures, they used what we can call reality-based design, all of which are persistent in the OBO foundry. For example, the current version of OntoSPM uses the tool OntoFox to myriad, or draw branches or terms, from the functional medical anatomy ontology, the information artifact ontology, the phenotypic quality ontology, the mouse pathology ontology, and the unit ontology. These are all in the OBO foundry and more or less compatible with the upper level basic formal ontology, which is also used here as the backbone of the project. OntoSPM uses one more OBO ontology, the full set of BFO relations. And this is complex and is continually in development and is intended for use according to the principle of minimal and shared relations in BFO or OBO compliant ontologies. Here, by relations, in protege software terms at least, I'm referring to objects, object properties, not declared subclasses or axioms. Using very few and mandated object properties to declare relations absolutely enhances interoperability between compatible ontologies. But because life is short and ontology is hard, it also requires much more work to both figure out and implement effectively refactoring relations, which are primarily designed for reference ontologies, to procedural ontologies requiring active inferences. I think the team behind OntoSPM does this absolutely admirably. They model surgical processes and actions as BFO processes, and from a presentation of theirs, quote, emphasis was primarily put on actions and on the entities participating in the actions, each mode of participation being modeled using roles, or BFO roles, unquote. Why this video is not called OntoSPM plus a couple of added terms? Well, first of all, maybe it should be. I think the procedural modeling part of the ontology can probably be extended to the pre-hospital environment. This is all fantastic, innovative, well thought out. And for a preliminary version, their terminology and entailments are very, very deliberate. There's a bit of a problem with how I'd use their representation of actions. The design is so thoughtful that I'm reluctant to call any part of the taxonomy be a little bit difficult to read. But here's an example of how certain actions are represented in OntoSPM. Look at the right side of the screen. We have the protege representation, where you see irrigating a body part for hydrating it as a subclass of manipulating action by human interaction. This seems to me to be problematic class terminology. I can suggest two reasons for this. The biggest one is related to their stringent adherence to the principle of using very few object relations. It's very difficult to represent actions, which usually include verbs, in part, without apparent nominalization, or extremely careful adherence to the parts of speech used in the established class hierarchy. Secondly, I think, and this is easy for me to say, with a combination of the W3C OWL time standard that they incorporate and distribution of their entities throughout the BFO hierarchy a little bit more widely, this sort of word clumping might be a little bit less necessary. But in fact, I really don't know the answer to this. This was actually my approach to terminology. We take the definition of hydration as a final stop. You can't see it here, but their definition is supplying liquid on the surface of a body part for preventing it from becoming too dry. Irrigating a body part for hydrating it is a term. So it's a process, an action, a manipulating action by human, irrigating an object, and all the is-a relations hold perfectly, but it has to refer to new object subproperties in order to make sense. And some of them, like realizes affected physical objects, extends the core relations anyway. And in the meantime, the term has been kind of turned into a sentence. Again, this is something that I really don't know the answer to in an issue in representing procedures. Granularity is extremely significant here. Most procedural actions should be terminologically mirrored as continuance or things that can be acted upon at an appropriate level of granularity. The first Onto SPM conference was held in April 2016. One point of outcome was that stakeholders suggested that they may in fact gradually include SNOMED and UMLS sort of things in later versions. You can see further information on Onto SPM and its rationale is listed below. Drawing from several sources, I present a single domain definition of protocol as follows. A detailed plan specification of procedures or treatment for care of injuries, conditions, or illnesses described in a comprehensive guide delineating the EMT's scope of practice. In the experimental EMT ontology, several higher-level terms were drawn from various OBO foundry ontologies. Branches from the Ontology for Biomedical Investigations, OBI, and the Mental Functioning Ontology, MFO, were used in more detail. The model for action representation was supported by Onto SPM, and cognitive and perceptual intentionality was enhanced by MFO. I used protocol as an information content entity under the aegis of the information artifact ontology, and subsets of protocols as subclasses. Medical tools and measurement devices are defined and used as BFO objects, as in Onto SPM, as are organisms and anatomical structures of organisms. BFO roles are assigned to Onto SPM's class of human actors. Without differentiating between acts, activities, and actions, Onto SPM offered the simplest solution, presenting an action as a BFO process, and that's it. I added the term human observation as a corollary to a subclass that I added to MFO, mental process attention. The goal is to use this class for a conglomerate of what MFO defines as consciousness with added intentionality. The idea is to allow for something like a scene size-up, where an entire spatio-temporal region is assessed, or in other words, observed toward a specific end in a particular domain context. Accounting for intentionality and interactive actions is something to develop in this sort of work.